few people have asked for some extra examples on naming alkanes. So I'm just going to give you a few little pointers and things like that. I'll do a few examples as we go. So remember to go back to your notes and to use the instructions that are here. So that's cycloalkanes, but there's also nomenclature of regular alkanes, right? So I'm just picking a few examples and we'll use these just to show the concepts. So when I'm looking at any given structure, what I look for are ends. So here I'm looking, these are ends that have carbons. And so the first thing that I really want to do is to identify the parent chain on my molecule. And the parent chain has to start from one of the ends, and it's going to be your longest continuous chain. So as I look at these three ends, I can see that this first one here, it's only one carbon at the end, and then it goes to a branch point. Here I have one carbon at the end, and it goes to a branch point. But here I go 1, 2. So I'm going to try and pick the longest one. I'm going to try to erase some of this stuff. And so that's where I'm going to start. That's why I've decided to start from this end, just so that I get my longest continuous chain of carbons. And so what I'm going to do is I'm going to follow this chain until I get to a branch. Now, I have to stop and I have to evaluate. I want the longest continuous chain of carbons. If I go down at this point, I only have one more carbon. But if I keep going straight, I'm going to get 2 carbons. So that's going to be my longest continuous chain of carbons. Everything that comes off of that is a substituent. So I have 2 substituents here and I have 1 parent. Now, I want to number my parent chain carbons so that the substituents have the lowest number possible. So I could start from back here and go 1, 2, 3, 4, 5, or I could start from 1, 2, 3, 4, 5. So what I want to do is I want to look at my substituents and what numbers are they getting. So if I went with the red numbers, I would have a 4 on the chlorine, and I would have a 3, so the 4 for the chlorine or the 3 for the methyl group. And so I could do that, or I could have a 2 for the chlorine and a 3 for the methyl group. And so the 2 and 3 are going to be lower numbers. And so what I'm going to do is I'm going to end up going with the blue numbers. So I'm going to go ahead and erase the red numbers because I don't want to get everybody confused. Okay. So here's my parent chain. My parent chain is 5 carbons long because each of these ends and any place where lines meet are carbons. So I'm going to kind of erase my highlighting so that you can see these a little bit better. Okay. So everywhere where I've drawn a dot is a carbon that is on the parent chain. So I have 5 carbons in the parent chain. So that's, I'm going through methyl. So remember your little mnemonic, me eat peanut butter in the pentagon. So that's me methyl, 2 ethyl, 3 propyl, 4 butyl, and then 5 pent. So this is going to be the prefix of pent. Pent. And then I see I have all carbon-carbon single bonds. So that's pentane. That's the parent. But now I also have to name the substituents. So when I look at the substituents, I have a chloro group, CHLORO, chloro group. And then I have 1 carbon. I can't count the blue carbons. I'm only counting the carbons that are in the substituents. So this is 1 carbon, and 1 carbon is meth. So this is methyl, YL, because this is a substituent and not a parent. And then the chloro is coming off of carbon number 2. And then the methyl is coming off of carbon number 3. And so whenever we do this, we're going to put our halogens first, and we're going to go alphabetical. So we're going to say that's 2 dash, because we always have a dash between a number and a letter. So it's going to be 2 chloro, CHLOR, 2 chloro, then another dash, because I got a number coming up, 3, and then I'm going to squeeze this in. 3, I never give myself enough room, methyl. And there's no space between the methyl and the pent. There's no space there, okay? On the next one, I see that I have a ring. And so I have to determine, is the parent the ring or is the parent coming off of the ring? And so if I look at the ring, I count my carbons. There's 1, 2, 3, 4, 5 carbons. But then there's only one carbon coming off of the ring. So whichever one is longer is your parent. So my parent is going to be the ring. So I'm going to go ahead and highlight all the carbons that are in the parent blue. Okay, here's my parent. Now I'm going to number my parent so that I get a substituent. Here's my substituent that gets the lowest number possible. So it's going to be 1. And then it doesn't really matter this way if you go clockwise or counterclockwise. It doesn't make a difference because there are no other substituents. So we know the parent is pent, and it's all carbon-carbon single bond, so it's pentane, but it's a ring. So this is cyclopentane. So that's the parent. The parent is cyclopentane, okay? And then we have to name the substituent. So I know that the substituent, this is the carbon. There's only one carbon here, so this is a methyl group. And it's coming off of carbon number 1. But remember that we're chemists and we're lazy, so a lot of times we just don't write the 1. So it's methyl cyclopentane. There's no spaces, no spaces. Let's see, got another one for us. Okay, so now we have a ring and it has multiple substituents. And I have to know, is my ring longer or is the stuff coming off the ring longer? So let me count my carbons. I have 1, 2, 3, 4, 5, 6. And then coming off of the ring, I have 1, 2, 3. So my ring is longer, and then I only have 1 here. Okay, so I'm going to number my parent chain to give my substituents the lowest number possible. So let's name these. 1 we know is methyl, because it's just easier to talk about once we have the name. So this is methyl. And then we have one that's 3 carbons long. So that 3 carbon long one is me eat peanuts. So it's propyl, right? And then we have to think about numbering our chains so we get the lowest number possible. And you also think alphabetically. So M comes before P. So we're going to give methyl the lowest number. Now I have to go clockwise this way, because if I go clockwise, I give my propyl group a 3. If I went the other way, if I still started here at 1 and went 2, 3, 4, my propyl would get a 5, and that's much too big. So we're going to stick with this numbering, 3, 4, 5, 6. Okay. So I want to name my parent first. So it's a cyclo. So it's cyclo. And then we have 6 carbons. So that's hex. And then they're all carbon-carbon single bonds. So that's hexane. So we have cyclos. I see LO. I missed a L. And then I have a 1 methyl and then I have a 3 propyl. So I'm just going to extend it out. Okay, so I got 1 methyl and then a dash, 3 dash propyl. And notice that there's no space in here between any of the words. Okay. And I think we have 1. No, that's it. All right. That's it for now. I have one more I wanted to show y'all. Okay, here's one that has 4 different ends going on. So I have 1, 2, 3, 4. And you kind of got to decide where you're going to start. And so just like I said earlier, these 3 at the bottom, if I went in, that's only 1 carbon, right? That's only one. But then if I start with this one, I have 2 carbons. I have 1 there and 1 there. So I would start with that as my carbon that I'm going to start with for my parent chain, right? So here's a carbon in the parent chain, and I'm going to follow this line until I get to a branch point. Now I have to decide, am I going to go down or am I going to keep going forward? And the answer is you go for the longest one. So I'm going to keep going forward and I'm going to get to this one. Now here I decide, do I go up or do I go down? Well, it's the same thing. It doesn't matter. So you could have picked either way. So this is my parent, and I've dotted every single carbon that's in the parent. Now I'm going to dot my carbons that are substituents. So the red are substituents, the blue is the parent. So now I want to number my carbons so that they have the substituents have the lowest number possible. So I'm going to number my parent. I can see that here I have a substituent that's only one carbon away. Here I have a substituent that's 3 carbons away from the end. So I'm going to start from this side, but you could always just number them 2 different ways and see what works. 3, 4, 5. So we'll do it just to show you. 1, 2, 3, 4, 5. So do I go with the blue numbers or do I go with the green numbers? So with the blue numbers, I have 2 methyl groups, THYL methyl. Ooh, if I could write. So I have a methyl and a methyl. Okay, so if I go with the blue numbers, this would be a 3 methyl and a 2 methyl. If I go with the green numbers, I would still have a 3 methyl, but then I would have a 4 methyl. And so that's too big. So I'm not going to go with the green numbers, right? So let's just get rid of all those green numbers. Maybe. Oh, goodness. Okay. Here we go. All right. So we're just going to go with the blue numbers. And so I'm going to name this 3-methyl and 2-methyl. Okay. So now I've numbered them. I've given my substituents their information. Now I'm going to go and write the whole name. So I know 5 carbons long, that's pent. I have all carbon-carbon single bonds, so that's pentane. Now I have to put in my substituents. If you have 2 of the same substituent, you have to say that. So you're going to say it's dimethyl. And there's no space in there. There's no space between the dimethyl and the pentane. Okay. And then I have to say, where are those 2 methyl groups? Well, those 2 methyl groups are at position 2 and position 3, and we put a dash between the numbers and the letters. And that's it.